Okay, yeah. So as Dimas introduced, the question that we are wondering is what applications are uniquely unlocked or just unlocked by the TE stack. From the past two talks, I believe everybody has like a general understanding of what the TE stack is, and in general, what are some unique properties. But before we begin diving into the applications, I want to kind of like do a recap of the properties. First of all, the answer. What unique properties does TE have? I argue the first one is like this type of, I took the word from game theory. It's like called conditional recall, which essentially means that you are able to commit or credibly signal that you're forgetting some information after inspection, right? So I think in Andrew's talk, he introduced the TE stack as something that you can allow two bots that negotiate to enter into the same room and do all of the negotiation, inspect the other person's item, and then kind of forget after you leave the room, right? So that is kind of captured by this meme here, that you can unsee something after you see, right? Because that allows you to strategically or intentionally forget information. Okay, and the second property is this, I think, the unique differentiator between TE and ZK is that TEs allow computation over shared private state. And if you think about information age, right, like people talk about intents, what intents are is essentially like it's moving the boundary of property and the value from the action level to the intent level. So like, for example, this has been happening a lot, like in Google's case, right? In Google, the Google captures value at like the intent level. It mines the user's data and uses that data to kind of do better recommendation models. And that data is purely informational. It's not in action level thing, right? An action level is more like, oh, I have this skill, and then let's say like I fix plums, and then like the way for me to exchange value is to actually do the action. So then as we move more and more into this, value at information era, then high-speed computation over shared private state is really required for scaling, trading, and exchange whenever value exchange happens. Okay, and the third one is kind of like a combination of the previous two properties. We can name them something like encumbrance, right? So what encumbrance means is essentially you can put some secret into the TE and then allows an agent to act on the secret, and that agent can credibly signal to anybody else outside the TE that it haven't done any equivocation, right? It allows the agent to commit to non-equivocated actions. So in other words, in the left curve word, this just means like you can commit to no rugging. Okay, so using those three properties, what is like the application we enabled? On high level, it's like programmable authorization for Web2 accounts. Essentially, they allow you to make like one-time programs for your account, right? So how this concretely can happen is that you let the user log into some Web2 account, and then inside the TE you change the password, or you generate a new secret that controls the user's account that allows the user kind of to do delegated actions to the agent inside the TE. And due to the benefit of computation over shared private state and encumbrance, this also means that the user is able to program more authorizations. So essentially, at a high level, this just means that we are able to bring Web3 composability and programmability to Web2. Okay, of course, and this idea is not new. I'm like kind of, we've been exploring this area for quite a long time. So this paper, I think, is from 2018 called Delegatee. So the prime example you're seeing here is like Netflix account password sharing using TEs. And of course, I think in DEF CON, dark DAOs and designing smart contract with free will was like a follow-up work on this as is complete knowledge. And then finally, with Tom Cryer, I think he's seeing, 2016 is really old work. So what it does is essentially it allows you to do a TLS connection from inside the TE to prove some Web2 data was credibly fetched, so therefore allowing you to move valuable state from Web 2 to Web 3. So this may also remind some of you guys about the work on TLS notary and multi-party computation-based TLS. I want to stress that the difference between that and the TE approach is that that approach doesn't allow, doesn't allow or haven't really been any exploration in that area to explore credible writes. Like, so usually over there, you're using TLS node 3 to achieve this like credible read. You are like moving an oracle on chain. However, here, we are saying like we don't want to be mere mortals. We want to control our own fate, right? It's not like you're letting a god tell you what to do through an oracle. You want to, you want to say, here's something that I want to do, and then have that thing be realized. So then that's kind of like the opposite of an oracle, right? You're like letting an on-chain data or an on-chain agent to credibly control a Web2 account or Web2 action. So what's that? That's kind of like a prophecy, right? If you're like a prophet, when you say something, then that thing becomes true. Okay, yeah, and all of the previous work, I guess, can be kind of captured by this work in 2008 called One-Time Programs. It's like a classical cryptography paper, and if you actually look at the paper, the prime example you see in this is actually, I think, email delegation, right? So the scenario is like you go on vacation and then you want your agent or your friend to take over your account, but then obviously you don't want your friend to look at your other emails or like reply to emails that don't have the right title. So then you can develop a one-time program secured by cryptography to say something like, oh, the assistant Bob can only have the power to decrypt and sign emails dated September 2008. And upon realizing this, I tried to brainstorm some use cases with cloud, and it actually refused to talk to me. So what that means over here is that TE applications are so powerful that it's against the AI safety policy to even discuss it. So everyone here should realize that what powerful technology we're building, and the giants like Anthropic and OpenAI are actually afraid, such that they embed, forbid the knowledge from spreading, right? They're trying to have you unsee it. Okay, and then next I will demonstrate the power through like two very quick demos. So first one, we're at Modular Summit, must pay tribute to, the Celestia people. So Mustafa previously, I think, tweeted something like, wanted a platform where I can anonymously submit banger shitpost ideas to unknown city accounts that I don't want to tweet myself. I'm going to demonstrate quickly using TEs how you can achieve this. Okay, so over here I have my Twitter account. And then here's an app running fully inside TEs with attestation. I can share the hash in my link to my talk. So then I can kind of create a new NFT. So what just happened is that the front end redirected to a server running inside TE that does a callback to Twitter URL and then stores the OAuth token in OAuth 2.0, which is used by Twitter credibly inside inside the enclave page cache, which is in encrypted memory. So then it allows you to kind of mint an NFT that when redeemed allows somebody to tweet from your account. So over here, I'm fully testing on my own account. And of course, when somebody tweets from your account, you don't want them to tweet some random stuff, right? So then you can additionally define something called like a post safeguard here. So I can say something like, I guess, only TE posts. And then I can mint the transaction. So currently it's like on base Apolia. All of the costs, even to like the on-chain costs to base, are conducted inside the TE, by the way. Okay, so I think the NFT number 59. So this is like the NFT. So then I can kind of copy the invite link, and suppose now I'm opening a new browser to simulate what would happen if I send this to my other non-crypto friend. Okay, maybe the internet needs some time to load. So then let's just directly redeem under this account. Okay, so only TE posts. Let's say something like. Okay, let's say TE app accelerationism. Now let's redeem the NFT, and then it should like tweet from my account. Okay, yay! So this kind of yeah, works. So over there, what is essentially happened is that it did the whole Web 2 to Web 3 flow inside the TE by encumbering or storing my Twitter account inside the TE. Okay, and one real quick final kind of demo is that so previously there was this game called Mischief Plays Demo. So the game rule is really simple. It's like players can pay $10 to join before the start of the game, and the prize pool currently is like 112K, and then every hour people can vote to get other players out. So then naturally you can create some kind of DAO to collude to win this game, right? For example, you have a DAO that everybody joins and the members commit to not vote for each other. However, since this is a Web 2 game, the DAO's implementation is a bit hard. You can, by the way, you can visit proof.codes to see it. So how we implement the DAO is essentially we simulate a browser and hosted the email server inside the TE, and then you encumber or like delegate or take control over the user's account by an email link to change the password so the user cannot log in on their own and deviate from the DAO strategy, which is vote for others. Then inside the TE, you have an agent that takes actions on the user's behalf, which is like vote every hour for members outside the DAO. And all of those actions are done by in the simulated browser. So here are some architecture graphs. So all sounds great, but what really interesting just happened before this talk is that yesterday I did the same demo, and I think Andrew got very excited about this, such that he tweeted about this. And what happened is that, how's it going? Ethereum is a dark forest, but Twitter is also a dark forest. This is so crazy. Okay, we got literally Twitter or Mischief MEV'd. So before this talk, I got this email from Andrew saying hey, help, they are coming for me. Make the TDX, which is a type of TE, do something. So, okay, you guys have to realize what happened here is that Andrew tweeted about our strategy about using TEs to collude. And one of our coworkers happens to also play this game, but they are not inside the TE. And they, I think it's some Discord server where people are playing those non-TE based, just plain old human coordination servers found out, and they voted Andrew out. So he just dark forested the hell out of himself by broadcasting his intent or our intent to collude in this game. And what's sad is he tagged me and my ID in that post. And then what happened? This is the hour after Andrew got voted out. You can see here I received 120 votes to get eliminated from the game. So over there, what we can learn is that information does carry value, and broadcasting your intent into the public mempool really gets you screwed over. But on the good side, we're the sacrificial lambs to demonstrate the beauty of decentralized private coordination, right? We died, but the tech stops there. Because, okay, so the beautiful part of this is that people don't know what other members are in the DAO, because the DAO is running inside the TE, so there's no way for them to vote anybody else from the DAO. By the way, before coming to this talk, I've received the news that some Discord servers saw our, bad fate and wanted to integrate. So that really shows, TE product market fit starts from trolling people on games. Yeah. So if you want the space to be more interesting, do acceleration of apps via the TE stack. And okay, so what's next? Aside from apps, is we still have to remove infra choke points in the system, like security, liveness, and open hardware, which leads to the next panel. Thank you.